764, it tells us to examine the equation below. So I've rewritten my equation off to the right here, and I have x over 4 minus 5 over 6 equals 7. Now remember, anytime I have an integer, I can put it over 1 to make it a fraction, and that does not change the value. So that's what I would recommend doing, just because when we're working with fractions, it's easiest to work with all fractions. So part A tells us to multiply each term by 4, and they want to know what happened and do any fractions remain. So if I'm multiplying everything in my equation by 4, what I'm going to do is put it in parentheses first. Again, I am going to put my 4 as a fraction. So to turn 4 into a fraction without affecting its value, I'll just put it over 1. Now I multiply each of my terms by 4. Now I have 3 terms here. I have my x over 4, I have my 5 over 6, and my 7 over 1. These are my 3 terms. So I'm multiplying each of these 3 by my 4. Now remember, when we're multiplying with fractions, you just multiply straight across. So I'm going to get 4x. So I multiply my 4 and my x. Now I multiply my 1 and my 4. So 4x over 4 minus 20 over 6. And that is going to be equal to 4 times 7 is 28, and 1 times 1 is 1. Okay, so that's what we need to do for A. Now it says what happened and do any fractions remain. So what happened is the numerators got larger. The denominators stayed the same. And we do still have fractions. So we want to make sure that we're including that explanation for part A, because that is part of answering all parts of part A. Now B, it says if you have not already done so, decide how you can change your result from part A so that no fractions remain. Then solve the resulting equation. So I am going to erase my explanation now, so if you still needed that, just go back and pause the video. Part B. Now remember, we talked about in problem 763 that fraction bar means the same as division. So we can go ahead and divide now. So 4x divided by 4 would give me just x minus 20 over 6. Now 20 divided by 6 is going to give me 3 1/3, or 3.3 repeating, and that equals 28 divided by 1 is 28. Now we need to solve the resulting equation. So I have 3 1/3, a negative here, so I'm going to add 3 1/3 to get a 0 pair. Now I need to do that on the other side of the equation as well to keep it balanced. So 28 plus 3 1/3. I'm left with x on the left, and let me see, 28 plus 3 and 1/3 should give me 31 and 1/3 for x. So that's what we get when we solve for x. Now let's take a look at part C. So this all here, this was part B. Now part C, it says multiplying our equation by 4 did not eliminate all of the fractions. What could you have multiplied by to get rid of all of the fractions? Explain how you got your answer and write the equivalent equation that has no fractions. So what they're saying is, you know, it worked for when we multiplied everything by 4 like we did in our first step here in part A. We got 4/4 x, which gave us a nice just 1x. We also got 28 over 1, which gave us 28. Now we had a negative 26th, which gave us a negative 3 1/3. So we still had fractions. So they want to know now, is there something else we could have multiplied by so that we didn't have any fractions and we were working with just nice integers? Well, there is, and what we need to do in this case is find a common denominator between, if you go back to part A here and have a look at our denominators, we have the 4, the 6, and the 1. So we need to find a least common denominator among those, and least common will be the most efficient way to do it, but if you're stuck and struggling to find a common denominator, you can use just any common denominator, that's fine. And a little trick to do that is to just multiply all of the denominators together. So 4 times 6 gives me 24, times 1 is 24. So worst case scenario, you could do that to find a common denominator. Any one will work, the least will be most efficient though. So in this case, the least common denominator is 12. So I am going to write that equivalent equation that has no fraction. So let me show you how this works. I'm going to go back to my original equation, x over 4 minus 5/6 equals 7 over 1. I'm going to put it all in parentheses and multiply by 12 over 1. Now, when I multiply by 12 over 1, remember we just multiply straight across for fractions, so I'm going to get 12x over 4 minus 12 times 5 would give me 60. So minus 60 over 6, because 1 times 6 is 6, equals 12 times 7 is 84, and 1 times 1 is 1. Alright, so we still have fractions in this step, but let's remember that we can use that fraction bar as division. So a 12x divided by 4 would give me 3x minus 60 divided by 6 equals 10. And then 84 divided by 1 is 84. So this is our new equivalent equation that has no fractions. And you will see, if we solve this out like we're about to do in part D, we should get the same answer as we did in our original equation, hence the equivalent equation. So part D says to solve the resulting equation, so I'm just going to write that in here. So we are solving this equation now. This 3x minus 10 equals 84, and we also need to check the solution in the original equation. Now, we already solved the resulting equation from part C, so I do want to show you how for our new equivalent equation, we will get the same thing. So I could add 10 to each side, so I would have 3x equals 94. And if I divide by 3 on each side, I am left with x equals 94 divided by 3. And 94 divided by 3 would be 31 1/3. Pretty interesting, huh? So that is an equivalent equation. And, if we have done our math right, we should get the same answer. Now, it does tell us also, the last part here tells us to check our solution in the original equation. Now, there are a few important things to remember when checking your solution. The first is you always need to go to the original equation. So even though it has fractions, yes, you do have to go back to the original equation, just because there is a possibility that you or I or anyone could have done something wrong in our, coming up with an equivalent, nicer equation. So another thing to remember when we plug in to solve is that we need to use parentheses around our solution. So if I am doing my check, I am going to have my 31 1/3 in parentheses over 4 minus 5/6 equals, we can just leave it as 7. Now, if I put all of this into the calculator exactly as you see, so parenthesis 31 1/3 and parenthesis over 4 minus 5/6, you should end up with 7 equals 7. Now, don't confuse this with our solution. This 7 equals 7 means that our solution is correct. And when we plug it in to check, we are balanced on either side, which means yes, our solution is good and we have done the math correctly. That is all for problem 764.